Deep inside the heavily guarded server farms of the world's most valuable technology corporations, a silent war is being waged. The prize is dominance over the foundational layer of the next digital economy. Billions of dollars are flowing into artificial intelligence research, not merely to build smarter chatbots, but to secure an insurmountable lead. Yet beneath the staggering valuations and rapid product launches, a profound debate fractures the industry. What actually constitutes the true moat in this new era of intelligence? Identifying the core competitive edge for leading AI companies requires dismantling the machinery of innovation to see what truly powers it. For years, the prevailing wisdom suggested a simple formula: gather more information, apply more processing power, and the resulting system will inevitably be superior. But the reality of modern neural networks has proven far more complex. The competitive advantage in artificial intelligence rests on a volatile triad. It is a fragile equilibrium balanced between the raw, brute force of compute, the exclusive ownership of proprietary data, and the elegant, highly guarded secrets of model architecture. How a company weighs and weaponizes these three elements determines whether they dictate the future or become a footnote in its history. Consider the sheer scale of the hardware required to even enter the arena. Compute power is the undeniable physical constraint of artificial intelligence. Training a frontier large language model demands tens of thousands of specialized graphics processing units, running continuously for months. This infrastructure requires massive capital expenditure, specialized cooling facilities, and access to dedicated power grids. For newcomers attempting to challenge the established giants, this physical requirement acts as a towering billion-dollar toll booth. This reliance on massive compute essentially creates an oligopoly by default. The companies that can afford to build and maintain these supercomputers instantly separate themselves from the rest of the ecosystem. It transforms algorithmic development from a purely academic pursuit into a heavy industry. When a single training run can cost upwards of $100 million, the margin for error vanishes. Only a handful of entities possess the financial resilience to absorb the cost of a failed experiment at that magnitude. However, raw processing power is merely the engine. It still requires fuel. This brings us to the second, and perhaps most fiercely contested pillar of advantage: data. In the early days of generative AI, researchers aggressively scraped the public internet. They consumed digitized books, public forums, and open-source code repositories. But the public web is a finite resource, and researchers are rapidly approaching a horizon where high-quality, publicly available text is exhausted. This impending scarcity fundamentally shifts the balance of power toward entities like Google and Meta. These corporations do not just scrape the internet, they host it. Every day, billions of users voluntarily generate an ocean of highly specific, context-rich information within these walled gardens. From search queries and private interactions to real-time behavioral responses, this proprietary data represents a continuous, living stream of human intent. The value of this exclusive information cannot be overstated. While a startup might train a model on public domain literature, Meta can train its systems on the nuanced conversational dynamics of billions of daily interactions. Google possesses an unparalleled index of human curiosity through its search engine, mapping exactly how people ask questions and what answers satisfy them. This proprietary data is impossible to replicate by or artificially generate with the same level of authentic human friction. It forms a deep, unbridgeable moat. The hoarding of this behavioral exhaust raises profound questions about privacy and the concentration of knowledge. When the most advanced cognitive systems are trained exclusively on the private interactions of a captive user base, the resulting intelligence is inherently shaped by the commercial imperatives of the platform. The ethical debate surrounding this dynamic centers on whether the foundational models of the future should be dictated by the corporations that manage to enclose the largest portions of the digital commons. Yet the history of technology is littered with companies that possessed vast resources and still failed to innovate. This introduces the third crucial element: model architecture. If compute is the engine and data is the fuel, architecture is the design of the combustion chamber. It is here that organizations like OpenAI and DeepMind have historically staked their claim. They argue that the true competitive advantage lies not just in what you feed a system, but in how the system is mathematically structured to learn from it. Algorithmic efficiency can dramatically alter the economics of artificial intelligence. A superior architecture might achieve the same level of reasoning capability using half the compute power and a fraction of the data. Breakthroughs in how neural networks process context, manage memory, or route complex queries to specialized subnetworks represent closely guarded intellectual property. These innovations allow a leaner organization to outmaneuver a heavier, data-rich competitor by simply being smarter about how information is synthesized. This architectural edge is incredibly difficult to maintain. Unlike a massive server farm or a proprietary social network, a mathematical concept can be reverse-engineered, leaked, or independently discovered by rival researchers. The lifespan of an algorithmic advantage is often measured in months, not years. Therefore, companies relying primarily on architectural superiority must operate in a state of perpetual, exhausting innovation. They must invent the next paradigm before their competitors fully replicate the last one. The echoes of those early breakthroughs still resonate across the landscape. When DeepMind first demonstrated systems capable of mastering complex strategy games, the victory was not achieved by simply feeding the machine more historical matches. The breakthrough was structural. It involved novel ways of combining reinforcement learning with deep neural networks, allowing the system to discover strategies that human players had never conceived. That fundamental lesson, that brilliant design can conquer brute force, continues to drive the research philosophies of the most ambitious labs. This tension between proprietary resources and algorithmic brilliance has profound implications for the democratization of technology. The open-source community operates on the belief that architectural innovations will eventually disseminate globally, leveling the playing field. Independent researchers continually release highly efficient, smaller models that punch far above their weight class. They aim to prove that a massive, centralized infrastructure is not strictly necessary to achieve high-level utility. But the open-source movement faces a harsh reality when competing at the absolute frontier of capability. While open models become increasingly efficient, the proprietary giants simply take those same efficiencies and scale them up with their massive compute and exclusive data. The gap between the best open-source model and the best proprietary model may narrow in terms of specific tasks, but the absolute ceiling of generalized reasoning remains guarded by the entities with the deepest pockets and the largest server clusters. Binding these three pillars together is the most volatile and scarce resource of all: human talent. The engineers who possess the intuition to design novel architectures, the expertise to manage colossal computing clusters, and the vision to structure massive datasets are exceptionally rare. The competitive edge is often as simple as possessing the specific minds capable of orchestrating these complex variables. Talent optimizes the entire stack. A brilliant engineering team can write custom software that makes a cluster of hardware run 20% more efficiently, effectively creating compute out of thin air. They can design data filtering algorithms that extract higher quality signals from noisy information, reducing the need for raw volume. The interplay between human ingenuity and machine capability forms a feedback loop that rapidly accelerates a company's trajectory. Ultimately, the true competitive edge is not found in isolation. It is the compounding, multiplicative effect of all these factors working in concert. A superior model architecture trained on an exclusive, massive dataset, powered by an unparalleled computing infrastructure, creates an intelligence that cannot be matched by a competitor missing even one of those elements. The giants of the industry are not choosing between data, compute, or architecture. They are aggressively monopolizing all three. The societal impact of this compounding advantage is staggering. It suggests a future where the foundational layer of artificial intelligence is controlled by an incredibly small number of megacorporations. If the barrier to entry requires billions of dollars in hardware and access to proprietary ecosystems of human behavior, the garage startup narrative of the early internet era is effectively dead. Innovation at the frontier becomes the exclusive domain of the modern technological aristocracy. Recognizing this trajectory, regulatory bodies worldwide are beginning to scrutinize the mechanics of this dominance. The focus is shifting from merely regulating the outputs of artificial intelligence to examining the inputs. Antitrust investigations are exploring whether the control over massive compute clusters and exclusive data repositories constitutes an unfair monopolistic practice. The legal frameworks designed for the industrial age are struggling to map onto an economy where the most valuable asset is the capacity to process abstract reasoning at scale. The arms race continues to accelerate. As models move from simple text generation to complex, multi-step reasoning and autonomous action, the requirements for data, compute, and architectural brilliance will only intensify. The core competitive edge for leading AI companies is ultimately their ability to sustain an immense gravitational pull, drawing in the capital, the talent, and the information necessary to build the future. In this high-stakes environment, the victor will not just build the most successful product, they will define the cognitive infrastructure of the next century.